So, hello everyone. Today we are going to solve the CF contest, and the contest round is 1117, and it was a due to round. So, let's start with the first problem. And in this tutorial that I am recording, we'll be solving the first three problems of the contest that has been asked. So, let's start from the first problem. So, let's read the problem statement first. The problem name is creating abbreviations. So, the viewer was given a set of words S, which initially has contained n words, and then he performed the following operations n times. Okay. So the operation is that viewer forms a sequence of one or more words in the set from the set S. The same words may appear in the sequence several times, and abbreviation is formed from the resulting phrase. Then the behavior, whatever it is, adds the resulting abbreviation to S and now can use it as a subsequent operations as an ordinary word. You are given n initial words that were in the set S, and the set of abbreviations that the beaver formed determined whether the beaver made a mistake uh, and whether all these abbreviations could have appeared as a result of operation described above. Note that abbreviation did not necessarily appear in the same order which they are given. Fine. So let me open the whiteboard first. So what the problem is that we are given a set of words in the S, right? And from those words we are forming abbreviations. And how the abbreviation would be formed, it is stated there. The abbreviation is a sequence of the words produced by the first letter of the words in the sequence. For example, the sequence bits OK bits Redwood produces abbreviation BOBR. Means, oh, let me remove it. Where's the eraser? Eraser, where are you? So, abbreviation means, uh, let's suppose there is apple, sorry for the handwriting, apple, ball, cat, and dog. I hope so. You all would be familiar with this. So when we create the abbreviation of it, like the set of words, that would be A, B, C, and D. Sorry, D. And why I'm writing the capital words? Because it is stated that the abbreviation will be made in the capital words, right? So good to go. Yeah. Understood how the abbreviation will be made. Now, we will add the abbreviation to S and now use it subsequent operation as an ordinary verb. But there is a catch here. Like, let's suppose, let me take a test case, then I'll be able to explain it more properly. This is oh, that's- I don't know how to move all this. No, 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 no. Okay, I need to solve this. Okay, so, so what is this? You can move it anywhere. Oh, nice. Got the way how it works. So, um, so here we are given the set of words. We are given n set of words, and the abbreviation that would be formed is uh, M, right? Means the number of abbreviations that would be formed are M, and the number of words that are given to us in set S are N, right? These N are the words. The value of N is 6, and these are the abbreviations that are 4. For the uh, first case, we are solving this, I guess. This first case it is. And I think I have copied everything. Like all the 4 cases I have copied. I need to only solve this one. I need to copy everything. First, I'll learn that how to work with this keyboard. Sorry, I do- I do not. Sorry for the delay. So, mm, now I'll be proceeding faster. So these are the words that we are given. Uh, it is set S, and these are the abbreviations that could be formed with these words. So here is one thing that is given here, that note that the abbreviation not, no, not this one. Then we were at the resulting abbreviation S, and now here now used at a subsequent operations as an ordinary word. What it means that as the abbreviations are AG, BG, and CG, right? So here uh, did these abbreviations could be used as the subsequent words. Means we treat this abbreviation, and this abbreviation as words. So now we can form another abbreviation at ABC, right? So the fourth abbreviation is ABC. Even now, if there has been some higher value of M, then the next abbreviation could be A or AA, right? So that was the thing. So yeah, now we'll proceed towards the idea that we'll be needing to solve this problem. So how to change the color, is there is any possible way? No, I won't be wasting any time now. Let's make that. So what we'll be doing? We would be creating a set in which we would be storing all the first letters that were present in the words, like here. So if I solve for the first case, then the letters would be apple, sorry, apple, and banana, grape, cherry. Sorry, it is the set, so all the characters will be distinct. And A, G, B, C, A. G, B, C, and G. So G I have already told. So this is the set, and the values we are checking uh, from the sorry, from the abbreviation would be the first letters, right? So what we'll be doing is this is the set that we have created from the words that you have given to us, and we'll be seeking the first letters of each abbreviation, either it is present in the set S or not. If it is present, that means we are good to go. And even if a single letter that is not present in like in what in the set S, then uh, what will be printing if we are not able to? Yes, then would be printing no, because our abbreviation could not be made if uh, the letters are absent in the set, right? Wait, first check ANG. If ANG is present, yes, it is. Like, let's check it for the first case. So first we will check that ANG are present, yes, it is. Then BG are present, yes, it is. CG are present, yes, present, and are ABC present? ABC, yes. Everything is present. So that means our answer would be yes for this case. Right. We can also check for this one. It would be taking us time. Uh, Really sorry for the things that are happening because I am not familiar with this wide wave. Which one I was using is expired. It was now saying that I need to take a subscription for that. I never be taken. So yes, yeah, this I need to change the color. A oh, find it. Okay. A G. Oh, no, it's the same. It's the same example I had taken. I had taken. This. Our set S is A is only A because apple and avocado both contains phosphorus. And one thing more that we'll be storing it in a capital words, like the small words that are present in the words because the words are present in form of small letters. So we'll be converting it into the capital letter, then we'll be storing it. You can do it uh, anyway, either using the sky values, either using the built-in STL. So yeah, you can. And the abbreviations are B and BA. So we'll check for B and BA. Right. So is B is present in the set? No. That means our answer would be no directly. Right. Hope so. I was able to explain the overall idea that we are needing to solve this problem. So here is the implementation. This part. So here we are taking the inputs and here we are creating a bool vector. C means uh, you can also store it in a set that I have already told. So then we will be storing everything as files. And uh, as we move towards taking the inputs, like the words that were given to us. So we'll be marking each value of towards S2, right? As 0 minus. Yeah, we'll be showing the first word in form of the capital letter. Fine. And here, while checking the abbreviation, first we'll be taking the inputs, obviously. And when the first word that is not present in our vector or set, whatever you have used, then we'll be marking it as false, and when it is false, we'll be returning as null, right? Will be here. Means there is we only need a single element that is not present in the set, and then we'll be returning as false. That was the problem. That was the first problem. Right? So now it will moving to the second one. So it's a pretty long problem, but if you read it completely, you would be able to do it because it's the idea is pretty simple. So let's start reading the problem or the problem. And the problem name is kidney. Let me read it again. Kidney. Oh, so I have pronounced it right. So two giants, Dia and Ver, uh, are playing a game. Each giant has his own mountain range. You have already measured all these mountains and know that the heights of the mountains of in Riya's range are A1, A2 up to AN and the worst range are B1, B2 up to BN. With the mountains numbered from left to right, Bia and from Bia, right for Bia and left for Ver. Right. At the beginning of the game, the giants stand on the mountain numbered 1. Okay. They face each other and see all the mountains of their opponents. Right. It turns out that Beyond were are the connoisseurs, uh, con- connoisseurs of beauty, so the mountains in their ranges are arranged in non-increasing order. Right. Note this thing, huh? That the mountains that are given to us for these two guys are arranged in decreasing order. Right. In the illustration given below, there is an example of the arrangement. Let's leave it for now because we'll be taking the example. Dia and Var are very smart, so each turn they perform the same action. Specifically, the giant on his turn takes a boulder and throws it at the mountain in which the opponent is standing. As a result, the height of the mountain decreases by 1 if the giant on his turn sees that the mountain directly in front of him is higher with number 1 greater. Then the one he is standing on, he jumps into it. However, the giant discovers that he is standing on a regular ground. The height of current mountain is 0, and there are no mountains in the front of the him. He is admits defeat and admits defeat. So we have to go first. You know the game can last very long time due to enormous heights of the mountains and their qualities. So you want to determine who will win. So now let's understand the problem statement first. Let's understand what the problem is saying. So here we are given two players, let's say A and B, right? and both players are standing on the mountains. Let's say this is the type of mountain on which they are standing. I have draw the free diagram. So what these guys do is that they throw stones on each one. Like A will throw stones towards B and B will throw stones towards E on their particular turn. So in this game, one player go first. Let's suppose A is going first, and all the time A would be going first. That is clear in the problem. That is stated here that this player B goes first all the time. So what will happen when they throw a stone? That the mountains in which the other player is standing will decrease by one. Means the height of, let's suppose the height is 3, right? And the each blocks of height is as 1. So when he'll throw the stones on B, the A, so this height would be decreased, and the mountain that was earlier was at height 3 would trim down to 2. That was the problem. And one thing more, that when the height of the mountains in which one player is standing, on which the stone is thrown, is at, let's say, height 1, yes, and this we could say at height some 1 or 2, whatever. Let's say it is at 2. So what will happen if the player B is standing there and the player A attacked B? So let's say this is also 1. Oh, whatever, you can take any. In the problem, it is stated that the height difference would be 1, but let's say you can take 2. So when the stone would be attacked at B, so this height would decrease, and what B will do, B will jump to this mountain. Why? Because it is stated in the problem that when you are standing at the ground, and let's say you are standing on the ground and you don't have any mountains to climb, that means you have accepted the defeat and you have lost the game. That was the overall problem that we need to solve, and this is the case for both the players. Like when the left one attack, right one will try to jump to the higher mountains. If he is at the lowest point, like the lowest category of mountain, that is of block 1, and similarly for the both cases, like the left and the right. Okay, so what we'll do here is that, let's say we'll take this case. Mouse is black. 4 2 4 5 4 2 4 3 2 1 6 5. Means this is the height of the mountains of layer 1, that is 4 3 2 1, right? And the height of the mountains in which there is standing is 6 and 5. Yeah. So Let's say the first A is standing on the first mountain and B is also standing on the first mountain. So what will happen? That first uh, we say that A is proceeding uh, towards the game. So A will throw the stone on B. So the height of mountains would be 5 and 5. B would be standing where wherever it is. So again B will throw the stone and it will reduce to 3. Now again A will throw. It is 4 and 5. Again B will throw. It is 2, 3, 2, 1. Again A will throw. It is 5. Sorry. It is 3 and 5. Means this process will would be kept continuing, and at the last what will happen that what will happen? There will be only one, and here also there will be one. Like after a certain operations, one of the player would be standing at one, and when the stone would be thrown at him, he won't be having any such mountains to claim on, so he'll accept the defeat. So uh, it would be better if I draw this case. Like I'll I should pick a small one, which I can draw. This is small. This is a small. I guess. 1, 2, 4, 4, 1. 1, 2. Sorry. 1, 2, 4, 4, 1. I guess I have written right. 1, 2, 4, 4, 1. 2, 4, 4, 1. 1, 2, 4, 4, 1. It is 1, 2, 4, 4, 1. Means uh, player one is standing on a mountain which has a height of 4 and 4, and the player two who is standing on the mountain, first mountain has a height 4, 1, 2, 3, 4, and the second one has a height 1. This is player A, this is player B. So player A goes first. What he'll do? Let me change the color. He'll throw the stone first. So this will be decreased. Like the height of the mountain in which is standing will be decreased. Now B will throw the stone, so this will be decreased. Again A will throw, this one decrease. Again B will throw, this one decrease. Again A throw, this one decrease. Again B throw, this one. Again. Now when B was standing on the this block, like this particular block, and when he was hit by the stone, what he'll do is that he'll jump on this, like on this mountain. So now B is standing here, right? So now we'll throw the stone from here, and we don't A don't have any such mountains in which he could claim. So he'll A will accept the defeat and will be printing player number 2 as our answer. So now what is the overall idea by which we can solve the problem? Means 4 minus 1. What is the problem? So if we look at the test cases properly, what we can see is that whenever he changes the like the mountain, whenever the player will change the mountain, then there would be this much hits has already happened. A I minus a I plus one plus one. Whenever he changes the mountain. And you know one thing that he'll keep changing the mountains until he'll at the last mountain. That was the like overall concept that we need to solve this problem. Means he would be keep changing the mountains until he would stand on the first mountain. Even the problems could be made more complicated, but the idea is very simple. Like let's suppose in the problem that is given that the height would be one, but we know that the problem could say that the height are like means the player can jump up to the mountains which has some greater height, like let's suppose two, three, four, five, whatever. So the problem language could be could be made more complicated, but it is written in simple way, right? And the problem could also say that the mountains are not in decreasing order. Means you only need to you only care about the last mountains in which the player is standing. You don't care about all the mountains in which the player is like standing in the middle of the process, right? You only care about the last block in which the player is standing, and for that particular block, the hit, the number of hits he'll bear is that just the last value, that is AI. This is for the last block, right? So that was the overall idea by which we will be solving the problem. So let's look at the implementation of that of this particular problem. So the players we were given as B and one, and what we'll do, we'll keep adding this thing that I have already explained, and for both the players, and whenever the value of the hits that the player would bear that we have counted in this. This is for the first player. This is for the second player. When the number of hits of the first player is greater than the second player, then we'll print as one. And if the second player has more number of hits that he could bear, then we'll print as two. So yeah, that was about the second problem. Hope so I was able to explain it. Now we're moving towards the third problem. Right. So the problem name is spying on the viewer. So let's read the problem statement first and then we'll proceed. So how to do this? I need to learn this. Like how to use the whiteboard profile. So yeah. In this problem, we are given a rooted tree of n vertices numbered from 1 to n. Okay. The vertex number 1 is the root of the tree. The beaver initially located at the root travels to the tree to one of the beaver then located at the vertices numbered. Means in the rooted tree would be iterating and we sorry. We are given a rooted tree and in the rooted tree there is a player who need to visit the m dams that are present in any node that of that particular rooted tree which we are given. So You need to determine which of the m vertices that we were into. To this, what we can do that you can place the cameras on the edge of the tree. If beaver traverses an edge with a camera on it, we will see this. For clarity, we'll assume that after all the beaver's movements, you will receive a sequence of edges cameras in which beaver was observed passing through the corresponding edge of clarity. Using all the beaver's movements, you will receive a sequence of edge with cameras in which beaver was observed passing through the corresponding edge. Since cameras are expensive, it is necessary to use the minimum number of them sufficient to uniquely determine the viewer's destination. You are required to state the minimum necessary number of cameras, number of cameras, and the edges on which they are placed. They should be placed. Means in the problem we are given a rotate tree, and there are m positions like uh, those are denoted at the junctions in which the player, the viewer, need to visit. And what is your task? Your task is to determine that the what are those M positions in which the player has visited. And for that, what you are doing that you are placing the cameras on the edges in which the player is in which the player is moving. So, but the catch in the problem is that you need to apply the minimum number of cameras because the cameras are very expensive, obviously. So, and also you need to determine the positions of all the positions of the dams. Like dams are denoted by A1, A2, A3 up to AM, and you need to determine that for each particular dam that if the player is visited or not. And what need to give us the output K, the minimum number of cameras, and then in the same line, the K edges connecting the vertices, that for each case and where the camera need to be started, the vertex number. And what you need to print as the output first the number of the cameras that you need to place to detect the player's position, and in the same line, uh, what you need to print is the number of vertex on which you have installed the cameras. I think this would be the best case to explain this problem statement. Why it's not working? Yes. 612211. Sorry. 612211 and three. It is 531. These are the values of the parents, means the parents of each particular vertex, and the parents of vertices numbered from 2 to n minus 1, 2 to n. And what are these? These are the m These are M what? Junctions on which the player needs to visit. Right. So, so first, let's draw the routed tree for this case, and let's draw it. One, two, three, four, five, six. How I'm drawing? How I'm drawing this because we are given that for the first node, for the second node, the parent is two, right? For the third node, the parent is two. Sorry, for the second node, the parent is one because it's the second value we are given. For the second node, the parent is one. For the third node, the parent is two. For the fourth node, the parent is two. For the fifth node, the parent is one, and for the sixth one, two, the parent is one. So that's how I have drawn this. And if I mark the junctions that the player need to visit, those are five, six, and one. So what would be the optimal case, like in which we would be needing the minimum number of cameras? Think of it. Those would be when we put the cameras on the particular junctions. If we think in the broader picture, like this, but one thing that is given in the problem statement that travels through the tree to one of the beaver dams means the player who is moving in the tree will definitely visit, like who will visit the one of the beaver dams means it is sure that he would be visiting the dams. So that means you only need M minus one cameras to be installed. Think of it as, let's say you have installed, let's say the number of junctions in which the player need to visit are five, and you have installed cameras on four of them, right? And when you are asked that, oh, the player is visited on the four junctions that on which you have installed the cameras, and you say no, 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 the player has not visited on the four cameras that I have installed. What is the meaning of this? That means the player is visited on the first camera, like the first junction in which the camera is not installed. So means that you can handle five junctions by applying only five. Sorry, you can handle m junctions by applying m minus one cameras. Fine. Also, I have explained it well. So now that for, like, here there are three junctions, so you only need to apply two cameras, and where you will apply, you can decide by looking at the tree. Why? Because in the tree the lower nodes would be at the higher positions and the higher nodes would be at the lower positions. So it is always optimal to apply the cameras on the nodes which has the higher values. So for this case, the answer would be 3 and 5. Two cameras that you will apply. And if I talk about the nodes on which the cameras would be applied, that would be 3 and 5. Done and dusted. That was the overall problem that you needed to solve. And yeah, let's look at the implementation of this thing. Here we have taken the inputs of the parents, and here we have taken the inputs of the mm, what of the junctions in which the player need to visit. And first we have sorted the junctions, and after that I have created the answer vector in which I have pushed all the values except the first value, like the shortest one, and all the values on the array that is named as answer. And after that, I'll put it m minus one junctions because we are applying m minus one cameras on the particular junctions, like the larger ones, except the first one. And after that, I'll print all the values of the nodes that are present in the our in my answer array. So that was the overall tutorial that I wanted to explain, and hope so I was able to explain in a decent way. So yeah, that's all for this. Thanks for watching. If you are watching till now, bye. Enjoy your life.